Hello everyone, I am Pallavi and I am going to guide you in the journey of class 9th and 10th science in the simplest way possible. Before beginning with today's class, let me ask you a very interesting question. Suppose what will happen if we start cutting this piece of chalk into half forever and ever and ever? Today we find that point where you are physically forced to stop that. So today we are going to start with the chapter of class 9th, atoms and molecules. In this part of the class we are going to cover the following topic: laws of chemical combination, Dalton's atomic theory. We'll discuss the postulates as well as the drawbacks. Then the atomic symbols and very important topic, atomic mass. So let's begin with the introduction of this chapter first. In our NCERT, there is a brief history given for the atoms. Maharishi Kanand in 500 BC, he said that if we keep on cutting a matter, that was padarth, we get a very smallest part of matter, the smallest particle, and that smallest particle will be indivisible. Democritus and Leucippus said that the smallest particle will be called as atom. So atom itself means indivisible. So we can say that what is an atom? What is an atom? Atoms are the building blocks of matter. You are aware what is matter? You have discussed this in chapter 1 as well as in chapter 2. Atom is the smallest particle of an element which will participate in a chemical reaction. So it is going to participate in the chemical reaction. It is merely spherical shaped and we cannot even see an atom under a very high power microscope. Atoms may or may not exist individually. Do you know that an iron nail carries 10 raised to power 23 atoms of iron? But there is a question. How do we measure the size of an atom? As I told you that atoms is a spherical shaped, almost spherical shaped structure, so we can calculate its radii. Let us see how to calculate and what will be the units of atomic radii. The radius of the atom is measured not in meters, not in centimeters, it is measured in nanometers. So the atomic radii is measured in nanometer, or we can write small n and small m. Do you know 1 nanometer is equal to 10 raised to power minus 9 meter? So I can also write 1 meter is equal to 10 raised to power 9 nanometer. There are various examples given in our NCERT about the radius of different elements. Radius of hydrogen atom is 10 raised to power minus 10 nanometer. And do you know the radius of an ant, if we compare, it is only 10 raised to power minus 3 nanometer. So atom is so small. Now we have to see that how atoms interact with each other. So the scientist Anthony Lavoisier gave us 5 laws of chemical combination, but we have to study only 2 laws. Law of conservation of mass, and the second one will be law of constant proportion, and we can say law of definite proportion. Starting with the law of conservation of mass, it is very easy. Mass can neither be created nor be destroyed in a chemical reaction. So the mass of the reactant, will be equal to the mass of the product. And this is the law which is responsible for balancing the chemical equations. Let us discuss more about this. Let's learn about law of conservation of mass with the help of an activity. In this activity, we have to take a conical flask and we put the solution of sodium carbonate in the conical flask. Sodium carbonate formula is Na2CO3. And in an ignition test tube, we hang the ignition test tube in the conical flask and we put the solution of copper sulfate. Copper sulfate is CuSO4. After that, I shake the conical flask so that copper sulfate and sodium carbonate mixes with each other. So copper sulfate, which was CuSO4, reacted with sodium carbonate Na2CO3 and it formed copper carbonate CuCO3 plus Na2SO4. So on this side we write the reactants and on this side we write the products. So before mixing we just weighed them, the amount of copper sulfate and the amount of sodium carbonate we had, and after mixing we got the equal weight. So suppose if the mass of reactants were 23 gram, the product's mass was also 23 gram. So ultimately we can see that the mass of reactant is equal to the mass of products. Now let us solve a numerical based on this law. So let us solve this numerical. First we read the numerical, we write the data of the numerical and then we start solving it. So first read the numerical. In a reaction, 5.3 gram of sodium carbonate reacted with 6 gram of ethanoic acid. So the reactants are sodium carbonate which reacted with ethanoic acid. And what were the amount of sodium carbonate? Sodium carbonate was 5.3 gram and ethanoic acid was 6 gram. So after the reaction, the products were 2.2 gram of carbon dioxide and 0.9 gram of water and some sodium ethonate. So we had three products. One was carbon dioxide, which was 2.2 grams. Then we had water, which was 0.9 grams, and then some sodium ethanoate, and we don't know the amount of sodium ethanoate. What is the expected weight of sodium ethanoate? So we have to find the weight of sodium ethanoate. So according to law of conservation of mass, the total mass of reactants will be equal to the total mass of products. So here these are my reactants. So what is the total mass of reactant? Total mass of reactants should be equal to the total mass of products. So here 5.3 gram plus ethanoic acid was 6 gram should be equal to 2.2 gram of carbon dioxide, 0.9 gram of water and x gram of sodium ethanoate. So 5.3 plus 6 equals to 11.3 gram, and here 9 and 10, it should be 9, 10, 11, 1 carry, and it should be 3.1 gram plus x gram. So simply here we will subtract 11.3 gram minus 3.1 gram equals to x gram. So my answer will be 8.2 grams. So ultimately sodium ethanoate, the amount of sodium ethanoate will be 8.2 gram. So such kind of numericals can be asked from this law. Now coming to the second law, that is law of constant proportion, or we can say law of definite proportion. This law says that in a chemical compound, in a pure compound, the elements are always present in a fixed proportion by mass. Now what does that mean? Let us first understand this with the help of an example. Suppose I have to make a very nice lemonade. So to make that, I need 50 ml of water. I need the lemon juice of 2 lemons and 2 tablespoons of sugar. This is my recipe to make a perfect lemonade. And if I have to make a lemonade for 5 people, what will I do? I will multiply the ingredients with 5. So the ingredients will be in a proportionate value. Proportionate value. Now what does that proportionate means? So proportionate means to increase or to decrease the amount of the lemonade. What will I do? I will simply increase by the multiple or decrease the ingredient by the multiple, but the amount of ingredients, the quantity of ingredients for one specific lemonade will always remain the same. So similarly, in a compound, the amount of elements by their masses will always remain same. I will increase the amount of the compound if I am increasing the proportionate value of those elements. For example, I have an element A which will combine with element B to form an element C. And to form an element C, I need 2 parts of element A and 3 parts of element B. If I am altering the value of A and B, I will not get the desired compound C. Similarly, if I am altering the value of the amount in the ingredients which I needed for lemonade, I will not get the desired taste of the lemonade. So here I can also say that if the mass of the element is 2 gram and the mass of element B is 3 gram, then only it will form the element C. Or I can say the ratio of their masses will be 2:3. Let us take the example of a chemical compound which is ammonia. So suppose I took ammonia. The formula of ammonia is NH3 and the amount of ammonia, the mass of ammonia was 17 gram. When I decomposed ammonia with the help of heat, then I got nitrogen and hydrogen. The amount of nitrogen I had was 14 gram and the amount of hydrogen which I got was 3 gram. So I can say that the ratio of the mass of nitrogen and hydrogen was 14:3. So that is what? The proportionate value by mass of these following elements. Elements are nitrogen and hydrogen to form a compound which was ammonia. So in a pure compound, the elements are always in a fixed proportion by their masses. This is so simple. So let us solve a numerical related to that law. So the numerical says that hydrogen and oxygen combine in the ratio of 1:8. So hydrogen and oxygen combines in the ratio of 1:8 by mass to form water. So hydrogen plus oxygen forms water and the ratio of their mass is 1:8. What mass of oxygen gas would be required to react completely with 3 gram of hydrogen? So to react with 3 gram of hydrogen, what amount of oxygen do we need? So if 1 gram of hydrogen is reacting with 8 gram of oxygen, so similarly 3 gram of hydrogen will react with 3 into 8 gram of oxygen. So directly we can say 24 gram. So the answer will be 24 gram. And this numerical was based on the law of constant proportion. Now we had the laws of chemical combination. To compile all of these laws, we had a scientist which was Dalton. Dalton state many assumptions and these assumptions are called as postulates. So let us discuss the postulates given by Dalton, and this is also called as Dalton atomic theory. Dalton atomic theory gave us 6 postulates and they are very easy to understand now. So the first postulate was that all matter is made up of very tiny particles called atoms, and these atoms are indivisible and these atoms will participate in the chemical reaction. Very easy. The second postulate was atoms are indivisible particles which cannot be created nor be destroyed in a chemical reaction. So this postulate explains the which law? The law of conservation of mass. Coming to the third postulate, atoms of given elements are identical in mass and the chemical properties. This you have discussed in the previous chapter as well. Suppose I took hydrogen gas from India and hydrogen gas from America and hydrogen gas from Russia. Will the color of the element of hydrogen be different? The hydrogen gas will be different? or the other properties of hydrogen gas will be different? No. So the atoms of given elements are identical in their mass as well as the chemical properties, and in contrast to that, the atoms of different elements have different mass and different chemical properties. Easy. The fifth postulate was that atoms combine in the ratio of small whole numbers to form compounds. For example, I added nitrogen and hydrogen to form ammonia, and it was NH3. And it was NH3. So the ratio was 1:3. Similarly, if I combine carbon plus oxygen to form CO2, the ratio will be 1:2. So there is a small whole number ratio to form the compounds? Yes. Coming to the sixth postulate, that is the relative number and kinds of atoms are constant in a given compound. So the relative number and the kinds of atoms are constant in a given compound. This postulate explains which law? Yes, the law of constant proportion. See, Dalton gave us different postulates. He said that atoms are indivisible, but now we know that atoms are divisible. They can be divided into electrons, protons and neutrons. Further, he said that atoms of a given element are identical in masses. But we know about hydrogen, deuterium, tritium, and we know about argon and calcium, which are two different elements, but their atomic mass is same. So there were few drawbacks of this atomic theory. Let us discuss those three drawbacks specifically. As I said, that Dalton postulate had few drawbacks. He said that atoms are indivisible, but if we do some nuclear reactions on atoms will split into electrons, protons and neutrons. Then he said that the atoms of same element will have same mass and same chemical properties. But later on we discovered that the isotopes of hydrogen, which had the same atomic number, that is 1. The isotopes are hydrogen, deuterium and tritium. And their atomic mass was approximately 1008 gram, then 2 gram and 3 grams. So ultimately that postulate also had a drawback. Then he said that the atoms of different elements will have different atomic mass and different chemical properties. But the elements of argon and calcium, which have atomic number of 18 and 20 respectively, the atomic mass of both of them is 40 atomic mass unit. So these were the three drawbacks of the postulates given by Dalton, or we can say the drawbacks of Dalton atomic theory. Have you observed that again and again we are writing complete carbon plus oxygen to form carbon dioxide, hydrogen plus oxygen to form water? Can't we substitute all of these words with some symbols? Yes, Dalton does that. Dalton substituted. Dalton gave different symbols for the specific elements. So now let us see what were the symbols given by Dalton and what are the latest modern symbols of the elements. So Dalton was the first scientist to use symbols for the elements. What does Dalton do? He just used the words to describe, to give the symbol of the elements where they were found or at the location they were found. For example, he named copper as it was first found or first discovered at Cyprus. Similarly, he used different words, like he named gold element because in English the word gold means yellow. So gold came from the English word which means yellow. And the symbols he used were like, this was for hydrogen, plain circle was for oxygen. For gold he write capital G at the center and the boundaries were like this. But to form the compounds by using these symbols was very difficult. Suppose I have to make water as a compound. So what will I do? A structure like this will be formed. So to substitute that, we had modern symbols of elements which were given by IUPAC, that is International union of pure and applied chemistry. This organization named the elements by their first alphabet. For example, hydrogen, they use the symbol capital H. For oxygen, they use the symbol capital O. For few elements, what does they use? They use the first alphabet. For example, for aluminium, they use the first alphabet as capital and the second alphabet as the running letter and in the lower case. And for the others, for example, zinc, they picked up the first letter as the capital and any other letter which was in mid of the word as the second letter. For example, zinc, Z, N is small, Z is capital. Similarly for chlorine, it was capital C and small l. So this is how IUPAC gave the symbols of different elements. For class 9th, we have to learn the elements from 1 to 20 in the sequence. So let's learn together. I have learned the symbols in sequence with the help of a mnemonic. So I'll tell you the mnemonic, it's on you whether you have to learn by that or you are able to learn in the sequence as it is, that will be good. So let's write the mnemonic first. It is like this, that, hello, hi, listen, BBC, news of France, Netherlands, Nagaland, Meghalaya, all senior public school close around Kargil camp. So now let's name the elements. So starting with H is hydrogen, number 1. Number 2 is helium. Atomic number 3, Li, lithium. Number 4 is beryllium. Number 5, B for boron. Number 6 is C for carbon. Number 7 is N, is nitrogen. Then number 8 is oxygen. Number 9, France, F for fluorine. Then number 10 is Ne, neon. Number 11, Nagaland, Na is sodium. Number 12, Meghalaya, Mg, magnesium. Then we have Al, aluminium. Then Si is silicon. Number 15, public, P is phosphorus. Number 16, school, S is sulfur. Number 17, close, Cl, chlorine. Number 18, around, Ar, argon. Number 19, Kargil, K, potassium. And the last is camp, Ca, calcium. So in this order, you can learn 1 to 20 elements and their symbols as well as their atomic number respectively. And there is also a trick to remember the atomic mass. I'll tell you after the discussion of atomic masses. We know that what are atoms now. Let us discuss more about the molecules as well as compounds. For example, here I have mentioned that carbon, hydrogen and yes, this is oxygen. These are the atoms. When different elements combine together, so they will form molecules. So molecules are same or different atoms, when they combine together, they form molecules. And here, in the complete domain of molecules, I have mentioned compounds. And in the compounds, you can see we have different types of atoms combined together. So compounds specifically will be only the different type of elements combined together to form compounds. In the molecules, there is a specific bond which is called as the covalent bond. Covalent bond is formed between the two elements when there is a sharing of electrons. We are going to discuss about this in the next chapter as well. But in the compounds, we have covalent as well as ionic bond. So I hope by this diagram the difference between the atoms, molecules and compounds is clear. So can I say that all the compounds are molecules, but not all molecules are compounds? And you can explain this statement by quoting these examples as well. So let's learn about atomic mass now. See, the atoms are very small. We cannot determine their mass in grams. For example, the mass of hydrogen was found to be 1.67 into 10 raised to power minus 24 grams. So it is very complicated to measure their atomic mass in grams. So what we do is we measure the atomic mass in atomic mass unit. Atomic mass unit, which is written as AMU or as U individually. But before coming to this, we should learn that how the atom is having some mass. The atom is composed of a nucleus. The atom is spherical in shape. We have discussed this. So in the central part of the atom, we have nucleus, and in the nucleus we have neutrons and protons. And around that nucleus, the electrons revolve. So the mass of the atom is determined by the sum of neutrons and protons. But how to measure that mass? How to measure the atomic mass? That is the point. You must have visited to the vegetable vendor near you, and you have seen that the weighing machine, in the weighing machine, what he does is he put a relative mass of a piece of iron or something. For example, if he is measuring 2 kgs of tomato, he will put 2 kg of a iron block as a relative mass, as a comparative mass, so that when there is an equilibrium, so he will get to know that yes, this is the 2 kg amount. So it was very convenient that if we take a relative element to compare the masses of the rest of the elements present in the periodic table, we can compare them, we can find the atomic mass of that element. So we took that relative element as carbon isotope 12. Before carbon 12, we did took hydrogen and oxygen, but they were of no use because the values used to come in fraction and everything, and it was a very complex and they generated a very complex fractional values which were very hard to remember. So we took isotope of carbon 12 as the relative element. So we will compare the atomic mass of each and every element with carbon 12 isotope. So one carbon atom of carbon 12 isotope is having 12 atomic mass unit. So I can write that one atomic mass unit will be equal to 1 by 12th mass of C12 atom. Yes or no? So to define one atomic mass unit, I can say that one atomic mass unit is defined as 1 by 12th mass of C12 isotope atom. Easy. So Carbon 12 was taken as the relative element, and we can say that atomic mass is being calculated as a relative scale. It is more sort of a relative scale. So now let us learn different atomic mass of 1 to 20 elements. On the atomic masses of these elements, we have a very short trick. If you remember the atomic number of them, what you have to do is multiply or double the atomic number if the atomic number is a even one. And if it is a odd atomic number, then we have to multiply it with 2 and add 1 in it. For example, now see. And yes, the underlined one are the exception. Hydrogen atomic mass is 1. For chlorine it is 35.5 and for argon it is 40. Now let us see if this trick applies to everything else. So let us see how this trick we have to implement. For helium, the atomic number is 2. So the 2 atomic number is an even atomic number. So we will multiply it with 2, we'll double it and it will be 4. For lithium, this is an odd one. So it will be multiplied by 2 and we'll add 1. So 3 2s are 6 plus 7. Similarly, 4 will become 8, 5 will become 11, 6 will become 12, 7 will become 15. 7 into 2 is 14, 7 into 2 is 14 plus 1 will be 15. For oxygen it will be 16, for the fluorine it will be 9 plus 9 is 18 plus 1, 19. For 10 it will be 20, neon. Here Nagaland 11, 11 is an odd one, 11 into 2 22 plus 1 23. Meghalaya 12, so 24. Aluminium 13, so 13 will be 26 plus 1 27, 14 will be 28, 15 will be 30 plus 1 31, 16 will be 32. Chlorine it is 35.5. For the argon we have to learn 40 because they are the exceptions. For for the 19 one, for the potassium one, it will be 38 plus 1, 39, and ultimately for 20 it will be double the amount, 40. So this is the trick to learn the atomic masses of the elements 1 to 20. In the next part, we'll complete the chapter. We'll discuss about molecules, molecular mass, formula unit mass, valencies, ions, and mole concept. You can also download my handwritten notes from the description down below. Thank you so much.